For those of you who may be new to GeoCon, GeoCon was founded in 1979 and is recognized as the world leader in the manufacture of geotechnical and structural instrumentation. Currently, GeoCon has more than 160 employees, and as of 2022 is 100% employee-owned. Our main headquarters and factory, where all our products are made, is located in Lebanon, New Hampshire in the United States. Today's primary speaker will be Jeff Barrett. Jeff has over a decade of experience in data management systems and applications. He's one of our lead designers, contributing to the design and implementation of our complete GeoNet product line. I'll be acting as secondary speaker and background support. I'm Joelle Lang, GeoCon's training coordinator. I've been with GeoCon for 12 years, and my main role here is to collaborate with our instrumentation experts to deliver training opportunities for those seeking to expand their knowledge. Today's agenda will be covering the ins and outs of GeoNet data logging systems. We'll start off with an introduction to GeoNet before transitioning into the specifications of each GeoNet logging solution. After that, we'll discuss real-world applications and how GeoNet is a solution equipped for a variety of monitoring applications. Finally, we'll discuss powering options for GeoNet and data management software and tools. And with that, I will turn the reins over to Jeff.
Thank you, Joelle, and thanks for everyone for joining this afternoon. We'll start the presentation off by giving an overview of the design philosophy and the logger architecture. This is a little bit of a different approach that we've taken compared to some other products on the market. And we've really done this to provide the customer with the flexibility to come up with a solution that is really optimizing cost and reliability for their specific project. So looking at the architecture for the logger design, every logger starts with a base GeoNet board, and this board acts as the data logger component. So all of the devices have local data storage regardless of telemetry option. The second component is the onboard power. Power can be provided by 2 D-cell batteries or a rechargeable lithium-ion battery pack, depending on the product and power requirements for the site. From there, we add a sensor card, and the sensor cards consist of either a vibrating wire readout for any vibrating wire sensor in the market. We also have a 3-axis MEMS card for an integrated tilt logger. And then finally, we have a RS-45 card for our digital addressable sensors. And this consists of addressable vibrating wire sensors, any of our tilt products, so in-place inclinometers, tilt beams, and addressable temperature strings. From this base logger architecture, a number of telemetry options can be easily added. The options that we currently have are radio communication, which work through a gateway, and I'll get into that shortly. And then we also have cellular, Wi-Fi, and satellite telemetry options that we're able to add to any of the GeoNet loggers. Subset of the vibrating wire loggers are the 4- and 8-channel vibrating wire loggers, and these are unique in that they also have RS-45 bus capability, and this is used to expand the number of vibrating wire channels that can be read by these particular loggers. So the logger itself has sensor reading capability, and then through expansion, you can expand up to 64 channels on a single logger. And these variations are also available in the 4 telemetry options listed below. So to summarize the options available for vibrating wire, there's 1, 4, and 8 channel. That data transmission available through direct connect USB for all options, and then the various telemetry options you see there. And that's the same for our digital or addressable logger, as well as our tilt loggers. And then for the radio loggers, we have 2 options for gateways. We have a cellular gateway that connects directly to the GeoNet cloud and will transmit all the data collected from the loggers to the cloud. The gateway also has secondary storage, so you have that redundancy that not only is the data stored in the cloud, but you also have it locally on the gateway as well as on the individual loggers. And then for local networks, we have a local gateway which does not have cloud connectivity, but will allow the data collected from the mesh loggers to be stored and retrieved from a central location. We also have the vibrating wire expansion interfaces, which are able to expand the number of vibrating wire sensors on a single logger, and that's available for the 4, 8, and addressable or digital logger. So we'll start by reviewing the standalone loggers, some of the specifications and typical applications that our customers would use these types of products in. Many of these specifications are applicable across all of the logger variants, independent of telemetry. So the internal memory, we're capable of storing 1 million arrays of data. So as an example, a vibrating wire piezometer would have 2 pieces of data. We have the temperature and of course the raw digit reading. That would act as 1 array, so you could have 1 million vibrating wire readings stored internally on the logger. We're able to update firmware in the field. So if there's any new advancements, new sensor types that we add, these are field upgradable. One of the new things that we've offered with the GeoNet standalone loggers is that the tilt and digital models are a subvariant of the standalone logger, so the user experience is similar across the full product line. Able to expand up to 64 channels. With the standalone loggers, we are able to sample up to 1 minute intervals. This is longer depending on telemetry, and I'll get into that a bit later. We've chosen to go with a rugged aluminum enclosure. We find that a lot of our products are installed in fairly aggressive environments, and these have proven to be reliable in those environments. And we also offer a waterproof version of the standalone logger, and depending on the cable connection options that you choose, can be rated up to IP68 for 24 hours up to 300 feet. So a typical installation application for a standalone logger, this is really for the customer that doesn't need real-time monitoring, but wants to minimize the amount of site visits required to collect data. These are weather-tight enclosures, so they can be mounted above ground on a mounting pole, and typically we recommend that the cables be protected, but this is a typical installation that we might see in the field. Data can be downloaded through our agent software using a laptop. Download times are relatively quick, so this is a nice option if real-time monitoring is not required for the project. So at this time, I think I'll just stop for a moment to check in with Joelle to see if there were any questions in the chat.
We have one question queued up in the chat at the moment. It is, are there some Ethernet data logger solutions for GeoNet? Or any plans for it?
So Ethernet options are available through a module that we offer with the local gateway. So if you would set up a network of wireless data loggers, the data would be transmitted to the local gateway, and then through the Ethernet option that we offer, that data could then be transmitted over Ethernet. We don't have a direct connect Ethernet logger as a standalone unit. We only have the option to use that with our local gateway through a wireless network. So thanks for the question, and
second question just came through.
Go ahead.
What about Bluetooth connectivity for download of standalone loggers?
Yeah, so that's a good question. It's something that we've looked into. At this time, it's a trade-off of power consumption. Bluetooth uses a fair bit of power, so what we've opted to at this point is to have a direct connect download only. Like I said, it's something we are looking into, and as electronic components become revised and released, and those power consumption numbers are reduced, it's something that we'll likely add to the product line at a later date.
Okay, that's all we have for questions right now. So,
thanks, Joel.
You're welcome.
So I'll get into the wireless mesh network, how it works, and the options available. So this product line has been out for a number of years now, and it operates using mesh nodes through a radio network where data is transmitted to the gateway. We have a cellular gateway that transmits data to our cloud, and then using the API portal, you can manage the devices and use a secure token to access the data. Data can be accessed via GeoNet agent software or any third-party software through the API. So just an overview of how the GeoNet mesh network works. We've designed the product to work through a mesh that's capable of 4 hops. This is to optimize configurability in the field with power consumption. So this network works well where you're trying to reduce the number of gateways. You can have many loggers communicating around obstacles to a single gateway. There's various versions of the GeoNet mesh operating at either 1 watt, a quarter watt, or 20 milliwatts, depending on the frequency and local regulations. Currently, we have a number of countries approved for use, and there is a longer list here that we've worked through the approval process to get regulatory approval, but many of these radios are common in other countries. And what I would say is if there's any specific region that you're looking to deploy one of these systems, we can typically apply for and receive regional approval within 4 to 8 weeks, depending on the region. So just keep that in mind. If there's a country on the list that you don't see, that doesn't mean we can't operate there. The cellular gateways are configured with either LTE or 3G modems. They include a global SIM card, so there's no user supplied SIM card or activation required. The device is simply activated through the API portal with the click of a button. Because these use cellular communications, they require either mains power or a small 10-watt solar power to recharge the lithium battery. As I mentioned, the global SIM card goes straight to our cloud for data hosting, and all of the data billing is done through that portal, easily managed by the user, and all of the data can be accessed securely through the API through unique tokens. So one account can set up several projects and give access, restricted access to whatever data they'd like to share with the client. The local gateway essentially just includes a radio to collect data from the subsequent mesh. Data can be extracted through USB or RS-232 communications. So this is where the add-on Ethernet would come in, or if the user wants to use the user-supplied modem, either cellular or satellite, to access the data, that can be done through the local gateway. And this is typically powered just by 2 D-cell batteries where there isn't a modem included in it. The mesh data loggers include a small whip antenna at the top. There's various antenna options available if the antenna needs to be extended or a high gain antenna, but this is the standard whip antenna that you see here. All of the loggers operate on 2 D-cell batteries, and we've limited the sample frequency to 10 minutes just to ensure that all the data gets through the mesh and that there isn't any data bottlenecks. And battery life is really dependent on the mesh configuration, how large the network is, and your sample interval. But typically, battery life is 1 to 2 years on 2 D-cell batteries. The addressable or digital logger is a small form factor, can support GeoCon addressable sensors up to 32 devices with the internal D-cells, or up to 62 devices with external power. Again, operates on 2 D-cells typically, unless a larger string is required, and battery life is again dependent on network. And then finally, to wrap things off here for the loggers, the tilt logger has a biaxial sensor, so we calibrate 2 sensors for both tilt and temperature. There's multiple mounting options available depending on the site and the structure. This will operate again on 2 D-cell batteries, and see the tilt specs there. Really the precision value of 0.13 millimeters per meter, and the non-linearity, which is 0.09 millimeters per meter, are typically the most important. And then secondary, depending on the location of the logger in the field, and if there are anticipated large temperature swings, the temperature calibration can be very important. So we've been able to achieve a temperature dependent uncertainty of plus or minus 0.04 millimeters per meter, which is a very good value for some of these projects that have large temperature swings. So typical mesh network applications, obviously the basic principles of radio networks needs to be understood. We typically want these loggers installed high off the ground. 5 to 6 feet is ideal, with no obstructions around the antenna. This is a good view here of a dam project where a radio network set up with various loggers across the dam with clear line of sight. You need to be careful about the polarity of the antennas and make sure that they're all aligned in the same direction. Some of the other installation methods we've seen in the field, the picture on the left-hand side uses an external antenna. So this logger runs the antenna cable up to a gland at the top of the enclosure and uses an external antenna. And you can see in this photo, there's also a surge protection device utilized for lightning protection because the antenna is high up off the ground on a pole. The image on the right-hand side is the GeoNet logger with whip antenna installed in a secondary enclosure for security. The two important things here are that the backing plate is made out of wood, so we don't have any interference from a metal backing plate, and that the enclosure is plastic. So we've seen cases where these have been put in metal enclosures or with a metal backing plate, and the radio network, just will not be functional through those ferrous metals. I wanted to review a case study that, in our opinion, is a pretty extreme case. This was a project that we did last year with a client that came to us, really not with a real-time monitoring need, but they were doing baseline monitoring for a proposed open pit mine. And it was taking them a week to walk to each of these sites to collect data, which they had to collect once a month. So this is a very challenging environment for a radio network. Some of the stats on the site are roughly 2 kilometers by 2 kilometers with an elevation change of 720 meters. There's only one area where there was any cell reception, and it was weak at that. And there was 18 sites through this dense vegetation. So this was a very challenging project, but we worked through some of the design with the client and ultimately did a deployment last summer. And this is a photo of the environment just to show how challenging it is. And the initial deployment was done using zip ties and sticks in the ground just to assess the transmission of data through the mesh. There was various attempts to move the loggers out to more open areas by extending the vibrating wire communication cable. But ultimately, after a few minor relocations of the loggers, we're able to get the mesh network up and running and reliably transmitting data to the gateway. So this is obviously not an ideal environment for radio. And in fact, we mentioned to the client that it was unlikely that they'd be able to set up reliable communications here. But through a bit of trial and error and some long days out in the field, they were able to get this set up, which was really a testament of how resilient the mesh network is for some of these sites. So before I go into the network loggers, I'll just pause one more time and check in with Joelle to see if there are any more questions.
We have a question queued up here. I live in Canada with long, cold winters. Do these loggers work in very sub-zero temps?
Yes, so I also live in Canada with long, cold winters. And typically what we would recommend is the lithium D-cell batteries have a longer battery life. So those are recommended for the loggers. The gateway, if you're using a cellular gateway, comes standard with a rechargeable lithium-ion battery. Lithium-ion batteries, as you know, will not charge below freezing temperatures. So that needs to be retrofitted with a lead-acid battery to be able to be recharged and power the logger through long cold winters that Canadians love, right? So we have a few options on power at the end that I'll get into, but yes, we've deployed these in many northern climates, some in the northern part of Alaska as well, so they can work very reliably, as long as you're setting it up for success.
That's all we have for questions for this section, it looks like.
Great. So get into the network loggers, and this is, maybe a little bit of a different product approach than people have seen in the past. So this really resulted in a request from our customers to have a direct connect logger, for various reasons, but these loggers have built-in modems, either cellular, Wi-Fi, or satellite, and store data locally as well as transmit directly to the cloud. So with these types of loggers, there's no local radio network or any communication between the loggers. It's a direct connect to the cloud. So typical applications for a cellular logger, you can see one here installed on a pole. So with a small 10-watt solar panel. These are more cost effective for small networks. So if you have a project with 4 to 6 loggers, it's more cost effective to install direct connect cellular loggers than to install nodes with radios and the gateway. The gateway you can't connect sensors to, so it's more costly for these small networks. We've worked with clients that have installed radio networks in high traffic areas or where there's a lot of radio interference. That can result in some frustrating troubleshooting or delays in data. So, if that's a site where, this is an issue, the direct network loggers are much more reliable. Same if it's a dense urban environment with little or no line of sight, or if it's an active construction project where, the area is changing, so that line of sight will be questionable at some point in the construction process. These direct cellular loggers work very well and reliably, and you can move them around easily, and they'll still connect. Because all of the data goes through the same platform, if there's an existing mesh network that's operating, but there are a few sensors that are beyond the network, we have a number of clients that have just added these loggers outside to pick up a few more sensor locations without having to add a whole nother mesh network. And what we found in general, because of some of the issues with radio communication and having to replace batteries, that some clients just prefer to go with the direct connect cellular logger with a rechargeable battery, and it's almost set it and forget it, requires very little maintenance and delivers reliable data. The Wi-Fi logger application, we're seeing a number of underground mines where Wi-Fi is provided throughout the mine. That's a nice network to be able to connect into with our Wi-Fi logger. The photo you see here on this slide is inside of a building where there's a couple of liquid settlement systems installed underneath the slab, and these sensors are connected into a Wi-Fi logger that works through the building Wi-Fi. And dense urban areas that have Wi-Fi coverage, where the networks are secure and available, that's another option for data retrieval as well. And then finally, our latest product in the network logger is the satellite logger. These are obviously ideal in remote applications where you don't have other network coverage. There are some limitations with data frequency. We're looking at up to a maximum 2-hour sample frequency, and really most of our clients are looking at 6-hour readings or once or twice a day even. It's quite impressive how much the cost of satellite data communication has dropped over the years. It's currently 5 times that of cellular, which for remote applications, really isn't that expensive. So this is a product that we've been testing with various clients since summer of last year, and will be commercially available on our website next month. So we're pretty excited about this product. There's not a lot of satellite data loggers in the market right now, and we're seeing a lot of our customers asking for it. So we expect this to be quite popular going forward. So I'll stop there again, Joelle, just to check in to see if there are any questions.
We've got a couple questions queued up here. So the first one up is for cellular data loggers. Can we use local SIM cards from our cellular operators? IPs from these SIM cards have a private and dynamic IP.
Yeah, so the way that our API works is the cellular loggers are shipped with a GeoNet global SIM card, so you have to use a SIM card provided. It's activated through the API portal, and that's what allows the data to go through our API. So you're not able to add third party or bring your own SIM card for these devices.
All right. Next up, with this cellular data logger, can I connect to the data logger remotely to configure and set it up?
Yes, you can. So there's a USB port that you can connect to through agent software to configure anything you need to, but really that can all be done through the API portal remotely, and it's quite easy to do that way.
All right. With the cellular data loggers, can I retrieve the data files and use them with third-party software?
Yes, absolutely. So all the data that goes through the API, is stored in raw format, and then through the API calls, you can pull the data out either in raw or engineering units and use whatever software you would like. There's also a secondary method using our agent software where you can set up a data export. So you can export the data in a CSV file in various formats if you'd like to import it into some other type of software without using the API.
All right. And last question in the queue. Can we set up the cell gateway to a Wi-Fi system on a construction site to allow remote access?
Yes, so you can set up, a gateway. So what we could do is we can do a Wi-Fi gateway. It's not something that we currently offer as a standard product, but we have done them as custom products. So instead of having a local radio network to the gateway and then through cellular, if you have Wi-Fi available, we can do a custom gateway with a Wi-Fi modem instead.
All right. That's all the questions we had in queue.
All right. So just wrapping up the hardware, I'm going to go over the digital vibrating wire interfaces. These really serve the same purpose as a multiplexer. but the way in which they collect data from multiple sensors is different, and it's using an addressable approach with the RS-45 bus using Modbus protocol. So essentially, any of the loggers that have RS-45 communication capabilities, so they're here the 4.8 and addressable logger, that RS-45 communication interface can be connected through any number of vibrating wire interfaces, and we have a one-channel inline that you see at the top. We have an enclosure that is one channel, and then we have a 4 and 8. So essentially, how we're working with this is we're addressing each channel similar to how we would address an IPI string, that you'd address every position on the string. We would address every channel, and through Modbus, we're able to expand these out to 64 channels, or 32 units if you're using a combination of 1, 4, and 8 channels. So we found this very helpful for projects that have clustered vibrating wire sensors. It's obviously significantly cheaper to use one logger, whether it has telemetry or not, and these expansion interfaces to collect data from multiple sensors. The interfaces themselves do not require any power. It's all powered through the RS-45 bus, so there's no batteries or power requirements needed for those. So it's a pretty cost-effective and easy to implement solution for large clusters of vibrating wire sensors. And then finally, just wanted to mention that, because this works with Modbus, these vibrating wire interfaces can be used with, really any third-party data logger. We do offer an addressable bus converter to help with assigning the addresses for these sensors. We can obviously do it in the factory prior to shipping, but if you need the flexibility to change that or readdress, you can use that simple interface to do that in the field. And then finally, on the hardware, the power options. So this is a typical setup for a cellular gateway. You can see the internal lithium-ion rechargeable battery pack. That red cable is a quick connect that just goes into the barrel jack at the bottom of the gateway and is connected to a small 10-watt solar panel. So these gateways are pretty low power use. So a 10-watt solar panel is typically fine for the majority of applications. For friends in Canada and other cold places, there's a few options available. We have a external quick connect module that allows you to just add a small box with a lead acid battery, and then using the quick connect cable, plug that into the solar panel on one end and the gateway or cellular data logger on the other end. Or if you prefer, you can hook up your own lead acid, deep cycle marine battery and plug that into the 12-volt port. So I'll stop one more time just before I finish up on data management and check in with Joelle to see if there are any questions on that section.
We've got one question in the queue. Can I connect a Campbell data logger to the gateway to collect data from all Geocon data loggers in the mesh network?
Not easily. Some clients have configured that setup, but it's not something that we support or that we really recommend. If it's something that the client's adamant in doing, you can get a hold of us and we can talk you through how that's done and some of the challenges with doing that, but it's not typically how these are set up.
Okay, it's the only question that we have.
All right, so I'll just finish off here with data management and visualization. So all of the cloud connected devices are managed through the GeoCon API portal. It's a simple web-based interface that anyone can create an account on. This is a typical starting dashboard for a project showing the devices that are connected. So you can see here on a single project, you can have a satellite logger, a cellular gateway, and in this case, we have 26 nodes connected to that gateway, and then a Wi-Fi logger all in the same project. So, you know, the API portal doesn't care what telemetry option you use. All of the data goes to the same interface, and it's easily managed through this API portal. Going down a level, this is an example showing a few gateways and the mesh nodes that are connected, whether or not they're active, the type of sensor that's connected to it, and the last time it's seen data. And finally, in the device level, you have some metrics like battery voltage, logger temperature, mesh signal, the number of observations it's recorded, and this is where you can easily change the read interval. So depending on, you know, the status of the project, you may want to start out with, you know, a more frequent interval, and then, you know, taper off to something, you know, that'll generate a little bit less data for you to manage. We've got some power mode options here, and through the click of a mouse, you can activate or deactivate the cellular service in this case, or whatever telemetry you have. So if the project's no longer active, it's really easy to, you know, deactivate everything. You don't need to contact us. You can do that on your own, and then redeploy the hardware at a later date. Talk about GeoNet agent software briefly. So this is the software that we offer on our website, free for anyone to download. It's a PC-based software, and it offers some basic visualization for people that aren't looking for some of the advanced reporting and alarming features that some of the third-party software partners we work with provide. But this allows you to set up multiple projects and bring in data from a standalone data logger, as well as any cloud-connected data logger through the API token. So you can envision a project that had both standalone loggers where you're going out and manually downloading data, as well as some of it is hooked up to the cloud. All of that data can be managed in one place. Similar to the API portal, there's some metrics here about last reading, battery voltage, signal strength, so you can get a good snapshot of how the network is performing. And then from the visualization point of view, we offer basic time series graphing, so things like temperature, and then, you know, your engineering units for your sensor with time. And then we've also implemented full plotting capability for IPIs. So we have incremental and cumulative displacement and deviation. You can do a temperature profile and displacement versus time at selected locations along the IPI string. And then finally, I did mention the API integration and third-party software. We currently have integrations through the API with INSWA and Vista Data Vision. So any GeoNet data that is stored in the cloud is directly connected to these software platforms through a unique API token, and their full visualization and reporting and alarming capabilities can be used on that data. And then with the SenseMetrics integration, currently this is a hardware integration through the GeoNet radio network using the SenseMetrics thread as a gateway. And that setup has been deployed successfully across the world on many projects. And that uses the GeoNet hardware, but allows the advanced software features that SenseMetrics offer. So at this time, I'll pass it back to Joelle to wrap up the webinar.
Thank you, Jeff. So if you're interested in learning more about GeoNet or contacting us about pricing for a project, these are our teams that can help. Our sales group can assist you with an initial consultation as well as provide pricing and support through the sales process. Our technical support group offers installation, configuration, and troubleshooting support for new and seasoned users. And if you're looking to train personnel before they go out to the field, our training team can assist in setting up a custom training session on product hardware installation or software configuration. Request forms and our contact details are all available through our websites, so you don't have to worry necessarily about scribbling all that down. And then we do have some time left if anybody had any other questions that they wanted to send through. We invite you to do that now. And give that a minute if anybody has any more questions. All right, question just came through. With the cellular data loggers, okay. With the cellular data loggers, do those cards work in every country? This particular person is in Bolivia.
In general, yes, they work in every country. We would check that before quoting. There are a couple of networks worldwide that are not compatible, but something like 99% of the networks worldwide we're compatible with. So I'm not 100% sure about Bolivia, but there's typically one provider per country at least that we're compatible with, and it's important just to identify the cell provider that has coverage on your project, and for us to just verify that it's compatible.
All right. No more questions came through, so we'll just wrap the webinar up a little bit early. Thank you all for joining us today. It's been a pleasure sharing and discussing our GeoNet product line with you all. Please don't hesitate to reach out after this webinar with any questions you might have on GeoNet or any of our other products. Thank you and have a good evening or afternoon, depending on where you are. Thank you.
Thanks, everyone.